Studies Session 10, Measures of Central Tendency, Mean. Introduction. The frequency distribution with its graphic representations primarily shows the organization of data into a manageable form. They are the preliminary steps toward quantitative treatment of data. The method of statistically treating the distribution gives numerical distributions, which are the basic features of the distribution. This further enables concise and definite comparison of the features of one distribution with another. This study session will attempt to expose you to measures of central tendency, which is one of the types of numerical distributions of frequency distribution. Learning outcomes. When you have studied this session, you should be able to 1. Compute and interpret the arithmetic mean or average score for both ungrouped and grouped data. 2. Compute geometric and harmonic means. A measure of central tendency is a location or representative point on a scale, a central point where data are concentrated, centered, packed, or clustered with other scores scattering on either side. Such measures serve the following purposes. 1. It is a measure that represents all measures in a sample, which could be utilized in comparing the distribution with another. 2. A sample is a representative of a particular population. A measure of central tendency, therefore, describes indirectly with some amount of accuracy the population from which the sample has been drawn. Thus, we can estimate a measure of central tendency for a population from the knowledge of the sample measure of central tendency. Generalizations and predictions are therefore made beyond that of the sample to the population. This makes scientific research in the behavioral sciences and education possible. There are basically 3 measures of central tendency. These are the mean, the median, and the mode. 3 types of mean are used in statistics. These are the arithmetic mean, the geometric mean, and the harmonic mean. The arithmetic mean is the most frequently used, while the other 2 have a more restricted use. The arithmetic mean. On group data. Another name for arithmetic mean is average. To calculate the arithmetic mean for ungrouped data, add up all the measurements and divide by the number of measurements added. The formula for the calculation is given as x bar equals sigma x over n, where x bar is arithmetic mean, sigma is the sum of, x is an individual score, sigma x is the sum of x scores, and n is the number of measurements. Given that the scores in percent obtained by a student in 7 subjects are 43, 59, 61, 73, 55, 64, and 49. The average performance of the student on the 7 subjects is calculated thus. X bar equals 43 plus 59 plus 61 plus 73 plus 55 plus 64 plus 49 all over 7, which will give us 404 over 7, which is 57.71. From the above, summation x is 404, while n is 7. Regular frequency distribution. With scores in the form of a regular frequency distribution, the mean is computed using the formula x bar equals sigma fx over n, where x bar and sigma remain the same, that is, mean and the sum of respectively. Fx is x score multiplied by the frequency of that score. Sigma fx is the sum of fx values. N is the total number of scores, that is sigma f. Assume that a company recorded the number of accidents experienced per worker in a year, as shown in table 8.1, in a regular frequency distribution form. Calculate the average number of accidents recorded in the company for that year. Sigma fx will be equal to 18 plus 16 plus 42 and so on up to plus 0, which will give us 160. N, which is the total number of employees, is 31. Therefore, the mean x bar will be equal to 160 over 31, which will give us 5.16. The average number of accidents recorded in the company for the year is therefore 5.16, which may be approximated to 5, since number of accidents can only be expressed in a discrete measurement form. Grouped frequency distribution with class interval. The formula used for this frequency distribution is the same as that used for the regular frequency distribution. In fact, both distributions are group frequency distributions. While the former is without class intervals, the latter is with class intervals. For the group frequency distribution with class intervals, x bar is equal to sigma fx over n, where x bar and sigma remain the same, which is mean and sum of respectively. X is the midpoint of class interval. F is the number of cases in an interval. Fx, it means multiply each x score by corresponding f value. Sigma fx is the sum of fx values. And n, the total number of scores, that is sigma f. Look at table 10.2. Two employees scored between 90 and 99. Since the individual scores of the employees is lost in the course of grouping, we assume that two employees scored 94.5, this being the midpoint for the interval 90 to 99. This, however, is not a true representation of all intervals. Nonetheless, the error in any interval is small, and in the final calculation of the mean, most of the small errors tend to cancel each other out, bringing out a final result that is essentially correct. The geometric mean. The geometric mean is used as summary statistics in special situations which call for averaging of ratios and averaging rate of change. Generally, the geometric mean of n numbers is obtained by multiplying the n numbers together and finding the nth root of the product. Thus, if we have n observations, x1, x2, x3 up to xn, then its geometric mean gm is equal to the nth root of x1 times x2 times x3 times x up to xn. If we have two numbers, the geometric mean of the two numbers is found by multiplying the two numbers together and finding the square root of the product. For instance, if we have two numbers 7 and 5, the geometric mean of 7 and 5 is the square root of 7 times 5, which is the square root of 35. And that will give us 5.9. If there are three numbers, the geometric mean is found by multiplying the three numbers together and finding the cube root of the product. The geometric mean for 6, 9, and 8, for example, is the cube root of 6 times 9 times 8, which will give us the cube root of 432, which is equal to 20.79. When the numbers whose geometric mean is to be calculated are many, then this method of stepwise multiplication and finding the root would be problematic, especially when they are more than 3. This calls for the use of logarithms. The formula for geometric mean is log gm equals to sigma log x all over n, where log x is a logarithm of each observation and n remains the same. Sigma log x over n means the logarithms of the observation divided by n. The gm is then given as the antilog of log gm. Thus, the geometric mean gm of a number of observations is the antilogarithm of the mean of the logarithm of the observations. The table above shows the population size of 10 states in a country for 2 census records in 1980 and 1999 respectively. The task is to calculate the rate of population growth in the country. The steps involved are: 1. Calculate the percentage change in population for each state by expressing the latter population size as a percentage of the earlier. That is, divide the value in column 3 by that in column 2 and multiply by 100. For state A, this gives 25,500 divided by 20,000. Multiplying the result by 100 will give us 127.5. Enter this in column 4. Do the same for each of the other states. Number 2, find the log of each value in column 4 and enter this in column 5. For state A, the logarithm of 127 is 2.1055. Step 3. Sum the value of the logarithm in column 5 to give summation log x. This gives 21.7094. 4. To calculate the mean of the logs, divide the result in step 3 by 10, that is the number of items. This gives 2.1709. This is the log of geometric mean. Number 5. Calculate the geometric mean, which is the antilog of the value in step 4. The antilogarithm of 2.1719 is 148.2. 6. Interpretation. The problem is to find the average percentage change in population. The values in column 4 are not individual measurements but are ratios. And to average these ratios, the geometric mean was required. The value obtained at the geometric mean is 148.2. Because the change in population size was expressed in percentages, the average change in population is determined by subtracting 100 from the geometric mean. This gives the direction of the change, whether increase or decrease. A positive result indicates an increase in change, while a negative result shows a decrease in change. In our example, 148.2 minus 100 will give us 48.2. Thus, we conclude that there was 48.2% average increase in the population. That is, log GM equals to 21.7094 divided by 10. And that will give us 2.1709. Now the GM is equal to 1 over log GM, which is equal to 148.2. The harmonic mean. The harmonic mean is used in problems requiring the averaging of time rates. A rate is a ratio, and as such it may be stated in either of two forms. If two measurements are taken, x and y for instance, their ratios can be expressed as x over y or y over x. Take an example of the time taken by factory workers in a bottling company to assemble crates of drinks. In determining production rate in the company, two measurements would be required. These are the number of units produced within a given time and the time taken to produce one unit. Using n to represent the number of units produced within 1 hour, and T, the time to produce 1 unit. Then the production rate may be taken in either of these two forms: N over T units per hour, T over N hours per unit. The table 10.4 shows the time taken by 7 factory workers in a bottling company to assemble crates of drinks, and it is used to explain the computation of the harmonic mean. The production rate for each employee has been expressed in two forms: 1. The number of crates assembled per hour, and 2. The time taken to assemble 1 crate. The average number of crates assembled by the employees per hour is 66 over 7, which is equal to 9.43 in the first series. In the second series, the average time in minutes taken to assemble 1 crate is 49. 49 over 7 is equal to 7.07 minutes. To express the unit of measurement in the first series as in the second series, that is, to express the average crate per hour in the form of minutes per crate, observe the following calculations. 1 hour equals 60 minutes. 943 crates per hour implies 943 crates equals 60 minutes. Therefore, 1 crate will be equal to 60 divided by 943, which is equal to 6.36 minutes. From the first series, the average time to produce 1 crate is 6.36 minutes, while in the second series it is 7.07 minutes. This makes a difference of about 11%. This difference exists because the two series are not comparable at all. They have not been brought to the same basis for comparison. This is why the computation of the harmonic mean is needed. If so wish, to calculate the average time required in assembling 1 crate, and the data recorded are in the form of those in the first series, that is, units produced per hour, then the harmonic mean is to be computed. If the data recorded is as that in the second series, then the arithmetic mean computed stands. On the other hand, if we are to compute the average number of crates assembled per minute, and the information gathered are as those in the second series, that is, time per unit, the harmonic mean would be needed to compute that, while the arithmetic mean is adequate if the data are in the form of the first series. To calculate the harmonic mean, let us return to the case of calculating the average time required to assemble 1 crate when the data are used as those in the first series. The formula for the harmonic mean is 1 over Hm equals 1 over n times sigma 1 over x, where Hm is harmonic mean, n number of cases, and x individual measurements. The steps followed in computing the harmonic mean are presented using the data on table 10.5. 1. Find the reciprocals of each of the numbers. The reciprocal of a number is the inverse of the number. The reciprocal of 7 is 1 over 7, which will give us 0.1429. 2. Find the arithmetic mean of the reciprocals. This you do by adding the reciprocals and divide by the number of cases whose reciprocals are added. This gives 1 over n times 1 over x in the formula. In this case, it is 1 over 7 times 0.8246, which is equal to 0.1178. Number 3. Calculate the harmonic mean, Hm. Hm is the reciprocal of the mean determined in step 2. Thus, Hm equals 1 over 0.1178, which will give us 8.489 crates per hour. The harmonic mean gives the average number of crates assembled per hour as 8.489, as against 9.43 initially obtained when the arithmetic mean was computed. 4. To calculate the time in minutes required to assemble one crate, divide 60 by the resulting step 3. The 60 minutes make 1 hour. Thus, we have 60 over 8.489, which will give us 7.07 minutes per crate. By the harmonic mean, 7.07 minutes is required to assemble one crate of mineral. This is equivalent to what is obtained by finding the arithmetic mean of the rate in the second form. Study session summary. In this study session, we have differentiated between 3 types of mean: arithmetic, geometric, and harmonic. We stated that the arithmetic mean or average is calculated for ungrouped data by adding all the values together and dividing by the number of cases. For the group frequency data with class intervals, you have to multiply the midpoint value of each class interval with corresponding frequency value and add all the multiples, and then divide the outcome by the total number of cases grouped. The geometric mean is calculated when an average rate of change is to be determined. Alternatively, the harmonic mean is computed when the average of measures expressed in ratios is to be determined. End of study session 10. Thank you for listening.